everyone, my name is Gulshan Banu, working as an assistant professor AI and DS department. Today we are here to take a very new topic called as nature of environments. So this topic comes under the unit intelligent agents. So in this nature of environments, we have many different topics which is related to it. The first one is fully versus partially observable. Fully observable. An environment where the agent can directly observe or sense the complete state of the environment at any given time. For example, a chess game where the agent can see all the pieces and their positions. Partially observable. An environment where the agent has limited or incomplete information about the state of the environment. For instance, navigating city streets where visibility is limited by buildings and other vehicles. The next one is deterministic versus stochastic. So what is deterministic? An environment where the outcome of actions taken by the agent is completely predictable based on the current state and the action chosen. For example, a physics simulation in which the laws of motion are deterministic. Stochastic, an environment where outcomes are influenced by randomness or uncertainty. For instance, stock market prediction where future stock prices are influenced by unpredictable factors. The next one is episodic versus sequential. What is episodic? An environment where the agent's actions do not depend on previous actions or outcomes. Each interaction is independent and isolated. So what is sequential? The sequential is something in which an environment where the current action affects the future decisions and outcomes. For example, driving a car where each action, for example, turn, speed changes, impacts sequent situations. So what is static versus dynamic? Static is something which is very stagnant and we can't do any changes based on it. So what is dynamic? We can do changes based on it. As that, static is an environment that remains unchanged while the agent is deciding on actions. For example, solving a mathematical problem where the problem itself do not changes. Dynamic is an environment that changes while the agent is making decisions. For instance, navigating through traffic where other vehicles and pedestrians move dynamically. The next one is discrete versus continuous. So what is discrete? An environment where there is a finite number of distant states or actions. For example, a board game with a finite number of squares and pieces. What is continuous? Continuous is an environment where states or actions are represented by continuous variables. For example, controlling a robotic arm with infinite possible positions and velocities. The next one is adversarial versus cooperative. So the first one is an environment where multiple agents compete with conflicting goals. For example, playing a competitive games like chess or poker against opponents. The next one is cooperative. Cooperative is something in which an environment where multiple agents work towards a shared goal. For instance, if you have a coordinating multiple robots in a warehouse to optimize the inventory management. So in this, the first one is the adversarial and the next one is cooperative. The example itself states that when you play a competitive exam, you will be having some opponents and you have to work accordingly. So adversarial is something which is based on it. So the next one is cooperative. So in this, the environment where multiple agents work towards a shared goal. For example, if you're working in an institution and you are working for a very single goal and all are working towards together for a single goal, right? That is something which is cooperative. So in this nature of environments, we see different topics like fully versus partially observable, deterministic versus stochastic. The next one is episodic versus sequential. The next one is static versus dynamic. The next one is discrete versus continuous. The last one is adversarial versus cooperative. So yes, I guess that you might have understood the basic concepts of nature of environments in this topic. So in the next video, I assure you that I'll come with a very new topic and with a good explanation. So as of now, thank you.